That's why if you didn't buy the book, you might be struggling on the quizzes, okay? You have to understand the materials. If you're going to be a certified personal trainer, raise your hand if you want to be a certified personal trainer, okay? If you want to be a personal trainer, you have to read the book. There's no getting away or going around just reading the notes and trying to study for the test, because if you do that, yeah, you might pass the test, you might do well, but you're not going to understand the information. You're not going to be able to relay that information to your clients, and you might not last long as a personal trainer because you might injure your clients because you're not understanding the materials. So really, the reason why you have to understand exercise physiology is we have to figure out what are the risks, what are the benefits of exercise, what are the risks of not exercise, and then also it's more than just about working out, right? There's LDL, HDL levels, there's high blood pressure, low blood pressure, that type of thing. So there's more than just resistance training. So next week, or this Thursday, we're going to go over our screening evaluation, health status and behavior questionnaire assignment, which is due on 3/6. So we'll go over that this Thursday. And then next Thursday, we have our test 2. Okay? As always, if you ever want to, make sure that if you are, not doing that well in the quizzes, you got to do really well in the assignments, right? So making sure that you're really completing those assignments with as much detail as possible. Active participation and professionalism is obviously expected. This class does a really good job at asking questions, also giving me feedback, and doing what you're supposed to, like not being on your phones during class. So I do appreciate that. What's up, Carly? What's up, Eugene? Good to see y'all. All right, so let's go ahead and move into a little bit of functional anatomy. Let's go ahead and you can leave your stuff here. Let's move our bodies onto the floor. Just find some personal space here. So find some personal space. We're going to go review a little bit of functional anatomy because, well, I think a lot of us could probably use a little bit more functional anatomy. Raise your hand if you took anatomy and physiology. Okay. All right. So hopefully that's applying a little bit, right, to this class. Let's go ahead. We'll start standing. Okay. We're going to start with our head and neck, and then we're going to work our way down. We're going to move each major joint of the body, and then we're going to talk about what muscles we're using, and then also what planes of motion we might be in. Okay. So we're going to start with the neck. So we're going to perform a neck circle, or a controlled articular rotation of the cervical spine. So let's go ahead and just stand up nice and tall, squeeze your fists. What we're going to do is perform a neck circle, but very controlled. So when I move my neck, I don't want to move my whole body. So I'm just trying to control my neck. So when I bring my chin down, what is that called? When I bring my chin down? Flexion. Flexion, yep. Cervical neck flexion. Now when I move over and I look over my shoulder, what is that called? Chris?
Lateral flexion.
Okay, if I'm looking over my shoulder. Amy? Okay, rotation. Okay. Now if I bring my ear, if I laterally bend, that would be lateral flexion. Okay? And when I look up, what are we doing when we look up, Eugene? Be called neck. Hendricks? Extension. Yep. So we're going to go through a full rotation. So we're going to go neck flexion, rotation, lateral flexion, extension, rotation, lateral flexion, and then neck flexion. Good. Okay. Thoracic spine. Well, first with the cervical spine. How many vertebrae in the cervical spine?
5.
Almost.
7.
8. Okay. What was the analogy we used for remembering the vertebrae?
But on the functional anatomy PDF it said, yeah.
7?
I said 7 in the video.
Okay, it's 7. So 7, what's the kyphotic or the kyphotic curve? How many in the
12.
12?
The thoracic.
Thoracic, yep. Okay, and then what about lumbar? 5. So 7, 12, 5. So we wake up at 7, we eat. We have lunch at 12, and then we eat dinner at 5. So a good way to remember that 7, 12, 5. Okay. Thoracic mobility. So we're going to put our hands across our chest. What are we doing when I move my head down like this over my torso? What is that called? Thoracic what? Or spinal? Lindsay, what do you think? Spinal? Flexion. Okay. Now, when I move over to one side, what are we doing with the spine? Rotation. And then when we bend our shoulder down toward our hip, lateral flexion. And then when we go back, extension. Okay, so we're going to go through a full rotation. So try not to move your hips, just your upper back. So we're going to flex down, rotate, bend, extend, rotate, lateral flexion, and flexion. Good. What muscles are responsible for lateral flexion? Obliques. What are the 2 obliques? External, internal. Is my external up or below? Up, yep. So my external turns into my what? Internal on my opposite side, diagonally. The external oblique means what? Diagonal. So anytime you hear oblique, it means diagonal, okay? All right, glenohumeral joint. So the humerus meets in the glenoid fossa. All right, so if we move our arm across our body, go ahead and do that with me. What are we doing with our shoulder? What's the joint action?
Adduction.
What type of adduction?
Horizontal.
Horizontal. We have horizontal pushing and pulling. We also have vertical pressing and pulling, right? What plane of motion am I in when I'm pulling something down or I'm doing a shoulder press?
Frontal.
Frontal plane. Okay? There's not a lot of frontal plane exercises. What's another example of a frontal plane exercise?
Jumping jack.
Jumping jack, nice.
The lat pull down.
Lat pull down. Shoulder press.
Pulse.
Pull-ups.
What does squat be?
What type of a squat?
Side.
Lateral squat. Or lateral lunge. Okay, that would be in the frontal plane of motion. What dynamic stretches or movements could I also perform in the frontal plane? Like if I wanted to move from one place to another. What's that?
A shuffle.
Shuffle, yeah, side shuffle. So we're in the frontal plane. Getting your clients to move in the frontal plane is really important because we're always doing things sagittally, either on a bike, walking, lunging, squatting, deadlifts. A lot of that stuff happens in the sagittal plane. All right, so glenohumeral, we're horizontally adducting. When we bring our arm over our shoulder, where are we at now in joint mobility? What's our joint action here of the shoulder? Shoulder flexion. Good, Chris. Okay. And then if I rotate my shoulder forward, if I squeeze my fist and rotate at the shoulder, does anybody know what rotation that is of the shoulder? Internal rotation. Okay. Now when I reach back, okay, I'm not externally rotating yet, but I am starting to go into shoulder extension and shoulder abduction. Okay, so now I'm going to rotate my shoulder inwards, still an internal rotation. Okay, now we're in shoulder extension. Okay, shoulder hyperextension, external rotation, flexion, horizontal adduction, and down. Let's get the other shoulder. So it's flexion, or you can go horizontal adduction, flexion, internal rotation, all the way to extension, hyperextension, external rotation, reach all the way up and across and down. You can also go external rotation, internal rotation. So external rotation, internal rotation. A lot of our clients lack external rotation, so when you put their bar behind their back, they start doing this with their low back because they don't have that ability, okay? So which puts a lot of pressure on their low back. So if you can't touch your hands behind your back on both sides, then doing back squats, shoulder presses, and pull downs is only gonna make your shoulders worse, okay? All right, what about the elbows? Let's go ahead and extend the elbow. So we're in elbow extension, okay? Now when I bring my hands toward my shoulders, what is that called? Say flexion. Okay, are my forearms pronated or are they supinated? Supinated. Now when I go like this, what are we doing? Pronation and extension. Okay. When I'm in the anatomical position, what's the bone closest to my midline? Ulna. And the bone closest to the lateral side?
Radius.
And what's the pulse I get here? Radial pulse. It's right under the thumb. So this is a pulse. This is where we usually take the pulse of our clients if they don't have a heart rate monitor. We'll be talking about assessments, resting assessments on Thursday. We're actually going to be performing those assessments in class. So we're going to get in groups on Thursday. We're going to go over the step test. We're going to do heart rate. We're going to do a power test. We'll get you warmed up. All right, now for the wrists. So bend your elbows 90 degrees. Now when I bring my fingertips toward the ground, what are we in? Wrist. Extension, nice. Okay, when I immediately move my pinky toward the midline, ulnar deviation. Remember that ulna is right there. So ulnar deviation, and then when my fingertips go up toward the sky, wrist flexion, and then when they go out, radial deviation. Okay, so you can just perform those controlled articular rotations each way. All right. So what about the scapula? So we're gonna bring our hands next to our sides. Pretend you're holding onto a $100 bill on both sides. So we're not going like this. And the fingertips can only move up and down. Okay. So when I shrug my shoulders up, what are we doing with the scapula? Elevation. Okay. What about when I go back? Retraction. Good. All right. What about when I go down, Jamie? Lindsay? Scapula goes downward. Depression. Good, good. And then when my scapula moves forward, protraction. So we got protraction, retraction, elevation, depression. Okay, what muscles are primarily responsible for moving that shoulder blade around? Trapezius, your traps. What about retraction? Rhomboid major and minor. Okay. Remember, if there's a major, there's probably a minor. If there's a brevis, there's probably a longus. Okay, so just when you're looking at different muscle structures. All right, so we move the elbow, shoulder, scapula, neck, thoracic spine. Let's move our way down to our hips. Okay, if you need to hold on to something for balance, that's fine. Okay, if you need a table or anything around you, we're going to just try to balance on one leg. Now when I move that knee up toward the sky, we're in hip flexion. Good, Chris. Okay. Now if I rotate my foot so it goes toward my opposite shoulder. Hendrik? What do you think we're doing with the hip? We already ducted here. Hip flexion. We're rotating it, but what way are we rotating it?
Internal.
So it seems like it would be internal because our foot goes in, but our hip is actually going out. So if we're like this, butterfly pose, that's external rotation. So when we raise our hip, we're in flexion. We can externally rotate, and then we can internally rotate. And you can actually get a geometer or a measurement of the angle that you're able to actively get into. Okay, so you have external, internal. Do you think you have more internal rotation or external rotation?
External.
You have more external rotation. Yep. Okay, so let's try same leg, or let's switch it up. Going to flexion. What are we doing here? Hip abduction. Okay, what about when I bring my foot toward the wall? Doing two things here. Internal rotation and I heard extension. And then when I bring that knee toward the knee, adduction and extension. So we're hip adducted, hip abducted, extended, flexed. Okay? So let's start with your knee bent. Without moving your spine, see if you can extend your glute. Abduct, flex, and set down. Okay? Let's move our way to our hands and knees. And feet in front. All right, we're going to hold on to one knee here. We're going to turn the foot out. We don't need to know about, there is external and internal tibial rotation, but that's not something I don't think you need to know for any of the tests that they have. So when we raise our knee up toward the sky, what are we doing with our knee? Extension. And then when we bring it back down, flexion. So really just the knee and the elbow are what type of joints? Hinge joints. Okay, they basically just bend and extend. There is probably more rotation in your forearms than there is in your knees. Okay, knees are built for stability or mobility? Stability. Okay, do we want really mobile, twisty knees? No, just like we don't want really mobile, twisty lower back, just like we don't want really mobile, twisty neck. Okay, so there's definitely stable areas of joints, and then there's mobile areas of joints. What would be the mobile area, mobile joint? Hip and shoulder. So those ball and socket joints have the most range of motion. Okay, now ankle, you're gonna hold on to the shin, point the toe down toward the ground, or an ankle, Jamie? What type of flexion? Plantar flexion, okay? What about when the toe goes up toward the sky? Dorsiflexion. What do you think people lack more of, dorsiflexion or plantar flexion? Dorsi. So people typically lack dorsiflexion, which is one of the main causes of why some people can't get in the bottoms of their squats and end up compensating in other places and damaging their spine, basically because of the ankles. And we're going to go over squat assessment actually this Thursday. So all those resting assessments and dynamic assessments we'll actually perform Thursday. Now, what about when you can see the insides of my feet? Ankle inversion. Now, what about when everyone else can see eversion? So I like to think everyone else can see eversion, then inversion. I just know that's eversion for me. That's how I remember that. Okay? All right. I think we got most major joints. What about the muscles in my lower posterior limb? Gastroc, soleus, and what's the big tendon? Achilles. Okay? What's the muscle that connects above the knee? We're talking about those same, either the soleus or gastroc. What one connects above the knee, just right above the knee, on the posterior distal side of the femur? What's that? So it's the gastroc. The gastroc, the big muscle on that back end of that posterior side, connects above the knee just slightly. That's why when you stretch your gastroc, you have to have a straight knee. Where when you're stretching your soleus, you have a bent knee. So it changes the degree there, okay? So soleus connects below the knee. What about the muscles on your shin? So point those toes toward your body. Feel those muscles on the lateral anterior side of the shin. What bone is that on the outside? Fibula. And the bigger, tougher bone? Tibia. And what about that muscle that's on the tibia? It's the tibialis anterior. Good. And what about the yeah, you feel that?
Yeah.
You were running? Do you run?
Yeah, that's the one that hurts.
Do you run a lot? Or, yeah.
In the last couple of weeks.
Yeah, then that's going to be, might be turning into plantar fasciitis.
Oh,
We're actually,
way past that.
oh, way past that?
Yeah.
What about the muscles on the sides, lateral sides of the lower, what are these muscles here on the outsides? Starts with a P. So we have our perennial muscles, perennial longus and brevis on the outside here, okay? What about our quadriceps? Our quadriceps, how many muscles is our quad? 4, what are the 4? Rectus femoris, remember rectus means straight, just like your rectus abdominis. That's how I remember that, rectus femoris. And femoris is on top of the femur. Sartorius is not part of the quadriceps, but it is located on the anterior side of the thigh. So the sartorius is that S-shaped muscle that starts on the outer hip and connects on the inner knee. So we have our rec fem. What about our teardrop muscle here on the inner? Vastus medialis, okay? Or some people call it the VMO, oblique VMO, because it's diagonally shaped. So we have a rec fem, vastus medius. What about the lateral muscle? Vastus lateralis. And then what's underneath the rec fem? That's still part of the quad. Vastus intermedius. Wow. Emma, right? Emma actually did the best on the test. Give it up for me. Right? Do you need a study partner? You want to tell us your study habits?
Not much.
Yeah?
I don't know how I did well.
Well, what classes have you taken? Are you an exercise science major, right? Or HFE? What classes do you think have helped you the most?
Functional anatomy.
Functional anatomy. Okay, so I mean, functional anatomy as a personal trainer, I mean, it's obviously taken me a long time to figure this stuff out without having to look at my notes. When you're training to be a trainer, or when you're looking over all the review materials, it's going to be the time where you know the most about training. You don't want to lose that information. A lot of trainers, they gain the information and they become a trainer, and then they train the way that they have been training their whole lives, right? Bodybuilder, powerlifting, and then they try to turn their clients into bodybuilders, powerlifters. But that might not be functional for our clients. So that's why understanding functional anatomy, understanding, oh, I shouldn't have my client do a pull down if they don't have shoulder mobility, because I can actually damage their shoulder, right? Okay, what about, so we have the sartorius, which is on the inner side of the thigh. So we have our adductor complex. What are our adductor muscles?
The longest.
Longest, obviously, would be the longest adductor, brevis, and almost medius, MA, magnus, okay? We also have the innermost muscle, starts with a G, gracilis, and then another very small muscle that starts with a P, pectinus, okay? What about our hip muscles, the outer hip muscles? Up on the top, we have one that's located right on our pocket, TFL, tensor fascial lata. What is that responsible for? Stability or mobility? It's more of a stabilizer, okay? What about the outside upper muscle on our hip? This also aids in stabilization on one leg, in the frontal plane. So when we're doing side steps, this one turns on. If we put a band around our knee and do a squat, this turns on. It's our second biggest muscle, glute med, gluteus medius. And then obviously the biggest muscle of the body, glute max. That's why it's called the maximus. Is there any other maximus muscle? Nope. So that's why it's called the maximus. All right. What about our muscles here in our upper arm? Bicep brachii, and then there's one that starts with a C. Coracobrachialis. So everyone just look at her test while she's, well, you can't, right? I have you all separated, you can't. What about behind the arm, upper arm? Triceps brachii. Okay. What about the shoulder muscles? What do we call them? The front. We call the front. It's on the what side of the body? Anterior deltoid, medial deltoid, and then we have the posterior deltoid. Okay. Upper traps. We have different parts of the traps. Rhomboids. When we try to squeeze our shoulder blades together. What about the muscles on our chest? Pectoral major and minor. Yep, if there's a major, there's probably a minor. What about the muscles on the top ribs, so the anterior side? They're serrated. Serratus anterior, and we also have serratus posterior. What are the muscles of the posterior side of my body that run from my hip to my occipital lobe? What are the muscles that go down my midline of my back? Was it any major muscles you can think of that run down your mid-spine? Erector, yeah, erector spinalis, okay? You also have your quadratus lumborum, which are on each side of the lower back, which aid in stability and lateral flexion, okay? And I think that's pretty good, all right, for now. All right, so let's quickly review energy systems, and then the exercise physiology, and then we have a lecture PowerPoint on screening. So our phosphagen system is our immediate energy system. What fuels work for 1 to 3 seconds? Okay, ATP. Okay, and then how many rest seconds? Lindsay, do you know how much rest?
Is it 1 to 3 seconds?
So it fuels work for 1 to 3 seconds, but how long do we need to rest in order to get that ATP back to store? What's that? 90 seconds, good. Okay, and it's broken down by what? What's the enzyme that breaks down ATP? This is you might not remember this one. What's the enzyme? Not pyruvate, but we're getting there. ATPase. Okay, after ATP depletes, blank is used to fuel contractions. Carly? F?
Fat stores?
Not fat yet. Other Carly?
Sugar?
Not yet. Creatine phosphate. Nice. Hendrick. Okay. Creatine phosphate restores what? ATP to contribute to continue short bursts of how many seconds? Okay, so we're at 1 to 3 seconds here. 3 to 15 seconds. Good. Okay. An example exercise. Carter, what would be an example exercise using creatine phosphate? What? How long are we sprinting for? How many meters? Or how many yards?
40.
So more 40 yard would be how many seconds though? Okay, so yeah, I mean we'd be starting there, but I would say more along the lines of like 60 to 100 yard dash, okay, or a 3 rep max, okay, or 100 yards dash. Okay, recovery time for creatine phosphate?
2 to 5.
2 to 5, nice, Hendrick. Okay, intermediate energy, so work longer than 10 to 15 seconds requires the body to metabolize what? Glucose or sugar, nice. You can use either or, same thing. Okay, this is known as what when we're breaking down sugar? Glycolysis, good. Okay, blank is the storage form of carbohydrate. Glycogen, nice. Is that Lindsay? Nice. I can't see your face. Okay. Where is glycogen stored? And 300 to 400 grams worth of it. Gene? Where do we store our glycogen? And not the pancreas, but liver. Liver, do you think the liver stores 300 to 400 or 75 to 100? Okay. Getting there. All right, so the liver can store 75 to 100, but where do we store our glycogen? Our muscles. Good. Okay, so our muscles contain about 400 grams, our liver about 100. So we have about 500 grams of glucose. How many calories is that? It's 2,000 calories worth of sugar, okay, because 4 calories is worth every gram of sugar, okay? So glycolysis lasts for how long? Or up to? Okay, up to 3 minutes. Or, no, we're in glycolysis. So from 15 seconds to 90, nice. Okay, example exercise. What could we do for 90 seconds? Or activity? Okay, it could be, what's that? Now you're gonna do 90-second worth of mountain climbers? Could be circuit training. So like, I would say, so circuit training, because we're doing one exercise after another, we're gonna be in glycolysis, okay? Continuous energy system would be, when we're past glycolysis, we're starting to use fats, so we're in aerobic metabolism. Okay, and then blank sparks the Krebs cycle. So after you're using all the sugar, blank is going to be required to continue out aerobic metabolism. What sparks the Krebs cycle? Said it earlier. You actually said it yet last class. And Chris said it today.
Oh, pyruvate.
Pyruvate, yep. So once glycolysis is in action and we're reaching about, after 90 seconds, we start to release pyruvate, which sparks the Krebs cycle, which continues your aerobic metabolism, which we use mainly fats in, okay? Fuels effort lasting how long? Or more than how long? Nice, 3 minutes. An example exercise or activity. Like a 5K, yeah, nice. 5K, marathon, so anything that lasts more than 3 minutes. Okay, good work. Okay, what is used by the heart as a buffer to continue? Nice, lactate. Okay, lactate used to be thought of as the cause of that burning sensation. Look at this. Okay, what is the end product of sugar metabolism? Everybody know? I'm gonna let you try to figure that one out. Okay, what is the culprit behind burning sensation?
Microscopic tears in the muscle.
So burning sensation. Starts with H. So hydrogen ions, okay? So we used to think that lactate was what caused that burning sensation, but we're actually understanding it's actually ischemia, okay? So a low oxygen state would be ischemia, and the end product of sugar metabolism would be, what do y'all think? So it's going to be aerobic, oxidative aerobic metabolism. Okay, so when we're at the end state of sugar metabolism, when we're done with burning sugar, we're onto the aerobic energy system, or aerobic metabolism. Okay? Hydrogen ions are the culprit behind the burning sensation in our muscle tissue, which causes ischemia. Ischemia is low oxygen levels. Okay? And I think if you have, does anybody have any questions about energy systems or exercise physiology? Let's talk about the heart. Oh.
Yeah, I do. What is the Krebs cycle?
So the Krebs cycle is a stage or a process of when the mitochondria and cells start to fuel our exercise after 3 minutes. So the Krebs cycle is basically aerobic metabolism. So once we're done in the process of burning sugar, the pyruvate triggers the Krebs cycle to start to engage, and then we're able to use more oxygen and fats because it takes a longer time to break down fats than it does sugar. That's why we use sugar and creatine phosphate as fuel before fat, because it's harder to break down fat. Okay?
So if you want like fat burn, the Krebs cycle is like the best. What's so good about the Krebs?
So remember, we talked about the fat burning zone is a misconception. Steady state aerobic work, remember, continuous steady state work is only going to have a certain amount of benefits. To burn fat, you have to increase the intensity. So whether that's increasing the intensity during circuit training or increasing your muscle endurance, but also not running into too much cortisol, because that can have a negative impact. But I also don't want you to think that cortisol is a bad thing, because it actually, we need it to continue long amounts of effort. Does anybody remember?
Can you like tell if you're producing too much cortisol, like while you're in the activity? Like when you feel like stress? Like
Yeah, because remember, cortisol increases stress. So when we wake up, you may have an increased amount of stress, right? That is your natural cortisol. That's your natural cortisol levels working. And there's some people that say that caffeine actually messes with that process a little bit, especially coffee, like right in the morning. They say that you should wait a little bit because your cortisol has you energetic. And then when you replace cortisol with coffee, kind of messes that up a little bit. That's a different topic for a different day, though. I don't want to get too lost with cortisol. We'd probably talk about cortisol for a long time. Does anybody remember where cortisol is released from?
Pancreas?
Not the pancreas. It's above the kidney.
Spleen?
It's on top of the kidney. Adrenal gland. Okay. What else does the adrenal gland release? Adrenaline in the form of what and what? Norepinephrine. Nice. Okay, and epinephrine. Okay. What are the other glands or hormones regulators in our body? So we have one that's located in the middle of our skull. Pituitary. What does that release? Jamie, do you remember what that anterior pituitary releases? So it releases growth hormone. Okay. Growth hormone sends a response to the liver to create. Carter, what does the liver produce to create muscle protein synthesis to increase hypertrophy? Does anybody remember? Starts with an I. IGF, yeah. IGF-1. So what does that stand for, IGF-1? I stands for insulin growth factor, okay? IGF-1, okay? So that's one gland or one endocrine gland that we have. What's another endocrine gland that we have, or hormone? Thyroid, and what does that regulate? Hormones. What else does it regulate in our body? Metabolism, so heat, right? So how much you feel like temperature, it coordinates how to metabolize food. So some people with hypo or low thyroid may gain weight because of their thyroid's not able to metabolize those sugars, and you may store more fat than sugars. Okay? What's another gland or hormone? Or what's another gland that we have in our body? We have our anterior pituitary, thyroid. Okay, what are the gonad glands? What does gonads mean? It's our sex organs, reproductive endocrine system. So women have what type of gonads? Everybody remember? Ovaries, right? Yeah. What do our? Well, we gotta get there. What do we release? What's that? What are the gonads? So the gonads. The men have testes. The women have ovaries. What do they release?
Eggs, like the ovaries.
Huh? We're getting there. Yeah. So ovaries and testes secrete testosterone and estrogen. Okay. Do men, who has 10 times more testosterone? Men, yeah, I think. And what are the characteristics of testosterone?
More muscular.
Muscle, hair, okay. And what is estrogen a bad thing for men? What do men need estrogen for? And women? Bone strength. Good. Okay. And does anybody remember how we break down testosterone to create estrogen? What we use in that process is called estradiol. So when we create estrogen, or when men create estrogen from testosterone, it's called estradiol. Okay. All right. What any other glands, hormones that you can remember from the endocrine system? I think that's it. Got a couple more. We got one more. It secretes. Okay, that's human growth hormone. That's the anterior pituitary. Okay, so that's human growth hormone. We talked about that. Okay, our pancreas, right? Our pancreas over here. What does that secrete? Insulin. It does, but what about our hormone-wise?
Wait, is insulin not a hormone?
It is, but insulin regulates what? Sugar metabolism, right? So we're either insulin sensitive or we're insulin non-sensitive, but that's kind of a different topic. When we're talking about the pancreas either releases glucagon, okay, or yes, insulin. Okay, insulin. What is that going to do? Is that going to lower or is it going to lower our blood sugar or increase our blood sugar? It's going to lower. Okay. What about glucagon? What does that do for our blood? Increases blood sugar. So our pancreas regulates how much sugar we need depending on the activity, how much carbohydrate stores we have. Okay. All right. And then the last thing I want to talk about is the heart and fatigue. I know this is a great heart, right? So we've got our 4-chamber heart here. Okay, what do we call, what's this called right here? On our right side there. What's that?
Atrium.
Nice, even though it's a bad drawing. Okay, we got our right atrium. It pumps blood into the, the right ventricle. Okay, the right ventricle pumps blood to where? Not to the heart. We're at the heart. The right ventricle pumps blood to the what? It is going away from the heart, so it is an artery. But what artery is it?
The
Pulmonary artery, which sends blood to make it oxygenated. What oxygenates blood? The lungs. So we need to get oxygenated blood. So our right ventricle pumps to the lungs. The lungs oxygenate the blood, and where does it go after the lungs? So it goes to the left atrium, full of red oxygenated blood. Okay? So the only artery that has deoxygenated blood would be the pulmonary artery, which goes to the veins because it doesn't have oxygen yet. So oxygenated blood goes to the left atrium. Left atrium pumps the oxygenated blood where? Left ventricle. And the left ventricle pumps the oxygenated blood to where? The aorta. Okay? Aorta is the biggest artery. It splits out, goes out to the body. Arteries send oxygenated blood throughout the body. Okay? Arteries turn into count. Arteries turn into Jamie. Arterioles. Arterioles turn into, starts with a C. Capillaries. Capillaries diffuse deoxygenated and oxygenated blood with, so we got arterioles, capillaries. Capillaries send that deoxygenated blood into venules, which turn into veins, okay, which go in from our inferior vena cava and our superior vena cava with deoxygenated blood, and then we repeat that process, okay? So that's what they want us to know for the heart, okay? What happens to excess calories, or start with what happens to excess, what do all excess calories turn into? Fat, okay? So it doesn't matter if it's a protein, if it's a fat or a carb, it all turns into fat at the end if we're not actually using it. Okay. What about Epoc? What does Epoc mean? Excess post energy consumption. Excess post energy or oxygen consumption. So after exercise, we have an oxygen debt we have to repay. So that would be Epoc, okay? And then we have 3 different types of fatigue. Who remembers the first type of fatigue, which only requires a rest period?
General?
What's that?
General?
We're not at general yet. What's before general? Fatigue. Carter? Starts with an A. Acute. We have acute fatigue. General, and then what would be a type of fatigue that would require stoppage where we're hitting the wall? Central. Okay? Central meaning the central nervous system. General is also peripheral, and acute peripheral as well. Peripheral means just your limbs and your legs and your muscle tissues, whereas central fatigue is more of a nervous system, your brain and everything else shutting down because we don't have anything left in our body. Remember, acute fatigue just requires a rest period. That's your typical fatigue that you'll have during a workout. General fatigue is when you didn't eat a lot of sugar and you need to recover because you've kind of run out. And then central is you didn't eat anything and then you ran a marathon and you're kind of hitting the wall. It's like very extreme. All right, good work. Let's go ahead and sit back at our seats. All right. We have a couple things we'll talk about. When it comes to screening and factors that affect fitness, most of this module will be hands-on. So Thursday this week and Tuesday, we'll be doing a lot of hands-on work when it comes to factors that affect fitness. Okay? So we need to be able to identify factors that impact health and fitness. We should be able to understand the relationship between physical activity and quality of life. Should be able to define terms such as hyperglycemia, hyponatremia, and Ravido Myolysis. Should be able to understand why it's important to acclimate novice exercise to activity and identify injuries associated with common activities. So we have a genetic potential factor. So we have 60% is controllable factors and 40% is uncontrollable factors. So we have more control than we think we do, right? So 40% is going to be genetic, okay? Fitness is heavily influenced by genetics, environment, stress, and daily behaviors. The biggest and most strongest impact is someone with a sedentary lifestyle. That's going to be your most risk for lack of fitness and lack of health. Genetics dictates approximately 40% of uncontrollable factors, on average leaving roughly 60% of one's potential up to their behaviors.
What would like be a genetic factor that impacts it?
So race, age, genetics could be just your parents, the traits that that were brought down to you. Some people are born with genetic disorders that you change, right? So genetics is something that we can't control, right? Whereas our diet, our exercise, the people we come in contact with, what we do for work, all that type of stuff matters. So different things that factor in impacting fitness: genetics, age, and sex. Okay, environmental factors. We've heard of stories where people live near areas such as farms that blow pesticides all over the place, and that can be detrimental to health. Social factors: who you hang out with. Are we hanging out with toxic people that bring us down and give us low energy and increase our stress, right? Stress, that can be related to maybe not getting enough sleep. Typically, if you're not getting a lot of sleep, then you're going to be running on overdrive. Nutrition, choosing healthy options, and also calorie control. So being able to control your calories, the amount of food that you eat. And we have a whole unit on nutrition, so we're going to get in there. Levels of daily activity. I would say trying to get to 5,000 to 8,000 steps per day. 10,000 steps is great, but 8,000 steps is really good too. Education and economic factors. We know that people that are low socioeconomic classes and low education have lower health statuses. So, if you are a trainer or a teacher, it'd be good to try to work with those populations who need it the most. So physical activity impacts quality of life. So benefits psychological health, function, and stress levels. So it helps us think clearer when we work out. It helps us function better. It helps us reduce our stress because our heart is working. And it improves older adults' ability to remain independent. So does anybody have a person in their family that's being taken care of that's older in your household? Okay. We know that a lot of people become dependent on other people as they get older, and so we want to try to remain independent. That's why physical activity is really important for quality of life. My grandma, she's 93, but she still gets around her house pretty well. My dad helps feed her, but she has a little bit of both the independent-dependent lifestyle. Physical activity serves as the primary means of preventing controllable diseases like type 2 diabetes and metabolic syndrome. So type 2 diabetes can be controlled by working out, because if we are able to burn that sugar, we're not going to just store it as fat, and we're not going to have those high blood sugar levels if we're using that glucose in our bloodstream, right? Metabolic syndrome, does anybody know what metabolic syndrome is? It's a cluster of conditions: hypertension, hyperglycememia, and hyperlipidemia, or high body fat. So all three of those would be considered to be metabolic syndrome, because it all affects our body's ability to break down sugar in food. And quality of life and physical activity reduces the risk for premature mortality. Physical activity and the risk for injury. So increased risk for strains, sprains, or fractures. So strains is more muscle more of a muscle issue. Sprains are more of a ligament issue. Okay, so that's the difference between strains and sprains. Okay, it's hard to say. Or fractures without proper acclimation among novice clients. So our novice clients are at the most risk at injury. So if you've never worked out before and you're coming in, first thing you probably don't want to do is get them to like run a marathon, right? You want to probably assess them, do a questionnaire. We don't need to, go all the way, to our 5K in our first week, okay? Because we're going to have some knee and ankle issues if we start stuff like that, which are the most common. So possible metabolic or thermoregulatory issues. So there can be hypo or hyperthermia, so low or high temperature. So if it's very cold out, you can get hypothermia. Very hot out during a game, or if you're outside training, you can get hyperthermia. Hypo or hyperglycemia, so that would be working with our diabetic population. Hyponatremia, does anyone know what hyponatremia is? It would be low. We might cramp if we have hyponatremia. Not iron. Sodium. So natremia, that would be meaning sodium. So hypo, low sodium.
Yeah, so what is cramping?
So cramping is basically when you're either dehydrated, you don't have enough electrolytes. We have electrolytes like magnesium, calcium, potassium, and sodium. If you don't have enough potassium, you may cramp. Things like bananas, like people will have bananas or oranges because they have they're high in potassium. Really important for cramping.
How about when your legs asleep?
What's that?
Your legs asleep.
When your leg falls asleep.
Yeah.
That could just be when you're occluding the blood flow. And if your muscles are positioned in a way that kind of squeeze on an area and then you're holding that area, then you might get, that feeling of, what just happened, and then you can kind of move out of that. Some people might have limited blood flow because of nerves. So nerves can be pushed up against, and then it can either limit or increase blood supply. So sometimes that can be a neurological or nerve issue if you're not getting blood flow, because then it'll start to fall asleep. And so it might just be learning how to position those muscles into a way that allows for better circulation. So, and then Ravido Myolysis. Anybody know what that is? Ravido Myolysis. Very rare. Does happen, but it only happens probably in like a place like a boot camp or military, Navy SEALs could happen. So Ravido Myolysis is when the tissue gets so hot and you're working out so hard that the tissue starts to break down and get into your bloodstream. And it can actually be potentially deadly, okay? You probably won't experience this, but if you do, or the signs would be if someone is overtired, overexhausted, and just like really pushing hard. Like they're doing like 100 reps of bench press in the heat, and they've been just practicing it for hours. They might get a little ravido in their chest and start excreting out to their extremities, but very rare, okay? That's something that if you want to look up, watch a video on, there's a bunch of stuff on rhabdomyolysis. And then common injuries for popular activities, okay? Jogging or running, torn cartilage, tendinitis, plantar fasciitis, shin splints, okay? So if we are running and jogging without a flexibility program, or if we're running and jogging too much, okay? So in my opinion, running and jogging is, if you look at the studies on running and jogging, more than 50% of people are going to get injured by running. So in my opinion, do I suggest that to my clients? No, I don't, because it increases their likelihood of getting injured. What would I replace jogging with? 10 to 15 to 20 second high intensity sprints on the bike with a 30-second rest, repeated 8 times, done twice a week. Okay, and then maybe increasing intensity or changing the the output. Maybe you're gonna go 0.1 mile as quick as you can and then rest. Then you're gonna go 0.2 miles quick as you can and then rest. Not as quick as you can, 70-80% of your VO2 max. But then what happens when you recover after intense, your heart rate learns how to recover better, and that's what we're trying to improve is our heart. But a lot of times people will jog and run thinking, oh, I'm trying to benefit my heart, but they're actually increasing cortisol levels, which increases stress. And then also the torn cartilage and damage to the knees or ankles may be less likely to go back to the gym. Okay, what was your question?
What's your opinion about the Stairmaster? Should you walk up the stairs?
I think it's a great tool for developing some muscular endurance in the legs. I used to do that, I used to go to the gym and go on the stair climber. It's probably not something I would do anymore. Probably better things to do maybe for, maybe go 10, 15 seconds and then rest and recover, but continuous stair stepping might just kind of increase cortisol because you're going to be using a lot of sugar.
What about like running on a treadmill instead of like the road? Like would that be any better for like your joints because it's like lower impact than concrete?
I would say treadmill would be definitely less impact. And then obviously there's a lot of NFL players that run on underwater treadmills, right? Because they're trying to take all that pressure out. Runners are going to run though, right? I mean, people are like, I'm a runner, and you're not going to stop me from running, So I try not to tell people what they can and can't do, but I try to give them other solutions. So if they do want to get their cardio, there's other options. Or if you are going to run, why don't you run 10 seconds and then walk 20 seconds? And then do that 8 times and get the same benefit in your VO2 max as a 40-minute, long, slow duration training session. So you get the same metabolic and cardiovascular benefits from short bursts of intense exercise followed by recovery than you do with long duration slow cardio. So you can mix and match. Bicycling, ulnar nerve palsies, ischial bursitis, Achilles tendinitis, lower back pain. So yep.
Why would bicycling affect your ulnar nerve in your thumb?
It's a good question. Because it's depending on the bicycling you're doing, right? Because there's some bicycles where your arm, you're kind of locked forward and your elbows are bent. So, all this pressure and all this extra ischemia, hydrogen ions from keeping your forearms flexed on the bike and just squeezing the whole time, that can build ischemia, which increases the hydrogen ions, which if you're not getting oxygen blood supply, then you're going to have wear away of the nerves and tissue there. So that's probably why. Good question. Yeah, because there's some bicycles where you're holding on like this, and then there's some bicycles where you're holding on like this, but you got to be holding on to something, right? Achilles tendinitis, lower back pain. Lower back pain, why do you think someone on a bicycle would get lower back pain? Because you're flexed the whole time, right? You basically look like this. You're like this all day at work, and then you get on a bike. So sometimes it's not always the most functional thing. Swimming, shoulder pain obviously from repetitive movements or shoulder impingement syndrome. Quick test from FMS is to go like this, and if it hurts, that's a quick shoulder impingement test. FMS, functional movement screens. And then you have aerobic dance, you could have shin splints or plantar fasciitis, or that fasciitis, there's an inflammation of the fascia on the plantar side or the bottom side of the foot, and the epicondylitis or tendinitis, the tennis elbow. Has anyone ever experienced tennis elbow? I have. I used to get tennis elbow from literally playing tennis. There's all that force and pressure right here at the end of your swing, and just snapping that arm through and through can really have a lot of effect on the epicondylitis or the tendinitis on that elbow. All right, so for the last 10 minutes, I'm going to put you in groups. Go ahead and get in a group of, we need to make 5 groups. So let's have this 3 right here, at this slot over here. 1, 2, 3. We're going to go to that barbell over there. Hendrik, Carly, 3. We're going to go to this spot right over here. Me, person, and Emma. Go right here. Eugene's group. Yep. Eugene's group right here. All right, so at each station, there's going to be a piece of paper. We're going to have y'all be right here. Yeah, you're good. There's a piece of paper at your station, and there's an exercise that you're going to perform as a group, okay? In the next couple minutes, I want each person to perform a couple of the reps of the exercise, and then I want you to have one person is going to tell us what the exercise is and the muscles that are being used. Another person is going to tell us the joint actions, and the third person is going to tell us the corrective cues or any type of mistakes. The third person that's speaking, you have to also show us what those mistakes look like, or the person that's performing the exercise has to show us what those mistakes are. So you're going to see muscle actions, joint actions, and then any corrections or spotting. Okay? So perform each of these exercises a couple times for each group member, and then I'm going to have you present this with your group in a couple minutes. So you're doing a lateral lunge. So I have two options. You can use this. If that's too high. But you're going to go over the Yeah, it is. Yeah, I don't do bench. I think I got that. And I call it the rear foot elevated to those spots. It's not yeah, modify that. Or whatever one you choose is fine. I'd like each person to perform the exercise, and then decide who's going to perform, who's going to talk about the muscle actions, and then the spotting. Choose one person to be the model, and then two people can talk about it. So choose one model for the exercise, and then the other. Yep.
Great press. Great press. What'd you get?
So I guess going like too much into the hip, where it's like stable, or you can go too much. Give me a thumbs up when you think your group is ready. You good? All right. Let's go ahead. Let's turn our attention to the military press group, and I want, when you talk about your exercise, I want you to pretend that you're at a fitness seminar, and this is your favorite exercise you've ever taught, and you're super excited. Tell everybody about this exercise. All right, here we go. We're going to start right here. Everybody listen up.
Alright, so the muscles targeted are the...
Well, what are we performing first?
Oh, this is a upright row.
Shoulder press?
Military press.
Military press?
Military press. Okay.
Oh, yes.
Sorry. All right, listen up.
So the muscles are the deltoid, the anterior and the medial side, and then the tricep brachies on the back of the arm. Common errors are using your back and momentum, and the joint action or horizontal adduction of the shoulder and elbow extension.
And
Okay.
how you would spot is just like put your hands on like the outside of their elbow.
Show us how that would look. Nice. Clap it up for our little press. All right, try to be a little bit louder so we can hear you. All right, let's check out our lateral lunge group.
We have the lateral lunge. This.
muscles exercise are the glute median, the glute max, the TFL, and the hip abductors.
The primary joint action would be the hip extension, hip abduction, hip adduction, and knee extension.
So common errors are like excessive frontal plane or hip and knee translation. So basically just going like way too far, like I was doing it. And then inadequate range of motion. So like either not going far enough, I guess.
Nice.
And then bilateral knee flexion or narrow stance. So kind of like I guess just in here. Yeah.
Nice. Nice. Give it up for our guys. All right, let's go with our Bulgarian split squat, or you can also pull up the rear foot elevated split squat because not sure if it's from Bulgaria.
Take these.
Yeah, so we have the single leg Bulgarian squat. There's a lot of names for it, but the joint actions are hip extension and knee extension.
Okay.
The muscles involved, glute max, rectus femoris, bicep femoris, and the vastus intermedius.
Okay.
Some common mistakes is if I did it and my leg went behind me, technique the flexion of my hamstrings.
Can you show us what you mean by that?
Yep, so if I am going straight, so I can dip that way, take all the flexion in my glutes.
Nice. Good job, Bulgarian. All right, we can bring you over here a little bit so you can hear him. Good job on not having to use the sheets. I like that. Nice. Extra credit. All right. All right. All right, here we go.
Alright, we have the bench push-up. The muscles are the pectoralis major, anterior, anterior deltoid, and triceps.
And then the joint action would be shoulder horizontal adduction and elbow extension.
Some common mistakes are like, making your hands too narrow or too wide,
Yep.
and just not going all the way down and up.
Yep.
Motion.
Yep. Making sure they go all the way down, touch the chest to the bench press. Do it right bench press. All right.
We have the modified deadlift as hip extension, knee extension, back extension, and hip abduction.
All right. And a little wider.
And then the primary
Hands.
primary muscles involved are the glute max, gluteus maximus, rectus femoris, vastus lateralis, vastus intermedius, vastus medialis, biceps femoris, semimembranosus, semitendinosus, erector spinae, hip adductors, gluteus medius, and common errors for this exercise are rounding on the back, unsynchronized knee, hip and or back extension, and dragging the bar of your shin.
You can remember all that? All right, let's go ahead and take a quick seat before we head out.
I'll get you.
All right. We're gonna end it there for today, but let's go ahead and just quickly review some factors that assess fitness. So what are the two factors that affect fitness?
Genetic and behavioral.
Genetics and behavioral. Okay, what percentage is the genetics?
40.
40. And behavioral? 60. And what are some other factors that affect fitness beside, or that are part of genetics? So what factors from genetics play? Age, gender, nice. And what about behavioral? Diet, sedentary behavior, physical activity, friends, nutrition. There's a couple more. Education, stress, socioeconomic status. Perfect. All right, everybody, we'll see you on Thursday, okay?